In this session, we're going to talk about the remainder theorem. Now, this is just a component of polynomials, okay? So we just arranged the videos in a way that you're able to follow from the remainder theorem, you go to the factor theorem, how you factorize polynomials, how you solve using long division or synthetic division, and how you solve equations and inequalities as per polynomials. Okay, so like in this session, like we earlier said, we're going to focus on the remainder theorem. Now, you have to understand that the remainder theorem, the general form of when you find your answer should be f of x or p of x in that case, or in that regard. Let me say this is a factor, maybe our factor is just x minus 1. This should be equals to, when you divide, you get your answer plus the remainder that you find divided by the same factor or the divisor. Okay, this is very important for you to understand. Okay, let's say for example they give you to find they ask you to find the remainder of this polynomial. Now a polynomial is just, you know, in terms of functions, just a function that is raised to the power 3 and going up like that. Okay, let's say we're asked to find the remainder for, you know, for this equation. Let's say we're dividing by x minus 1. Okay, so what you're going to do is, this is called the divisor. Okay, this is called the divisor. You can also call it the factor. Okay, so you have to understand those for you to understand you know, the remainder theorem. Okay, so what you're going to do, you're going to equate this expression to 0. So x minus 1 is equals to 0. X is equals to 1, right? When the negative goes on the other side, it just becomes 1 like that. Okay, so now that you have this expression, for you to find the remainder, wherever there is x, you're going to be replacing what you found as x here. Okay, so what are you going to have? You're going to have 1 to the power 3, right, plus 2, 1 to the power 2, plus 4, 1 plus 10. Okay, so the remainder in this case would be 1 to the power 3, that is just 1, plus 2 multiplied by 1 square, that is just a 2, 4 multiplied by 1, that is just a 4, plus a 10. Okay, so what are you going to get as the remainder? So 1 plus 2 plus 4, that is like 7. 7 multiplied by 10, that is like 7 plus 10, that is like 17. Okay, so this will be our remainder. Okay, so now how are you going to express it in that form? So in that form, like we said, how do you express it in the form? So you say f of x, in this case that's your polynomial, divided by the divisor. The divisor in this case, or the factor, is x minus 1. Okay, this is equals to the answer that we found. Okay, what have we found? We found that it is you find the quotient. Okay, but in this case, let me just put the quotient, because we're going to do a video where I find the quotient using the long division method or the synthetic division method. Okay, okay, plus then the remainder that we found that it is 17 over the factor itself. Okay, in this case is x minus 1. Okay, so what are we talking about? If you are given 17, this 17 is dividing by, let's say, 4. Okay, this is going to give you 17 divided by 4, that is like 4. It will give you a remainder of 1, right? It will give you a remainder of 1. Okay, so your error goes to 1. So when you divide, it is 4. So how are you going to express it in the actual form? The polynomial itself divided by the divisor, which is 4, or the factor, it will give us the coefficient or the quotient of 4, plus we said you put the remainder. The remainder in this case is 1 over the factor, which is 4, like that. Okay, so this is how you represent. Okay, let's solve another question. let's say you're given to find, the remainder of, let's say, f of x is equals to 2x to the power 3 plus 4x plus 2x, let's say, plus 1. Okay, let's say this is dividing by x plus 1. Okay, so what I'm going to do, again, you're going to equate this to be 0, so x plus 1 is equals to 0, so x in this case will just be a negative 1. So what does it mean? Wherever there is x, we'll be replacing by negative 1. Okay, let's just do that. So what are you going to have? You're going to have the remainder in this case will be equals to the remainder in this case is going to be 2 negative 1 to the power 3 plus 4 negative 1 plus 2 negative 1 plus 1. Okay, so now when you simplify this, what are you going to have? Negative 1 to the power 3, that is just a negative 1, and multiplied by 2, that will give us a negative 2. Then a 4 multiplied by negative 1, that is just gives us a negative 4. So we have a negative 4. Okay, then a positive 2 multiplied by a negative 1, that will give us a negative 2. So we have a negative 2 plus a 1. Okay, so our remainder in this case would be negative 2 minus 4, that is negative 6. Negative 6 minus 2, that is negative 8. Negative 8 plus, what am I doing? Okay, this was supposed to be squared here. Okay, so this is squared. Yes, that's how they follow. So this is supposed to be a positive. Nope. This is supposed to be, it's this one which is supposed to be a positive, because 1 squared, that will just give you a positive 1, then yeah, multiplied by 4. Okay, so that's how it's supposed to be. Okay, then what are we going to do? So your negative 2 and your negative 2 and negative 2 give you negative 4. Negative 4 plus 4, that is a 0, so you just have a 1. So our remainder in this case, it will just be equals to 1. Expressing it in the form, we're just going to say, we'll say f of x in this case divided by, what is our factor? We're saying is x plus 1. This will be equals to the quotient, okay, plus the remainder that we found, that is just 1 over the divisor or the factor itself. So this is how we use the remainder theorem.